Welcome to Grayon Math. The figure shows a semicircle where B is a point on its diameter AC so that AB equals 6 and BC equals 12. The line perpendicular to this diameter meets the semicircle at D. The semicircles with diameters AB and BC drawn as shown meet at meet AD and CD at E and F respectively. Find the distance between E and F. But before we go to the solution, may I request you to please like this video? Okay, so first thing that we have to do is we need to draw a line joining points F and B. And we observe that these two segments along with the diameter BC forms a right triangle because of Thales theorem. And also same with EB, if we join these 2 points by a line, then this also makes this triangle AEB as a right triangle by Thales theorem. Okay, so next thing is we observe that this length DC is actually a straight line. And since this angle at F is actually a 90-degree angle, then this other angle beside this is should be also 90. And same with this at point E, the angle beside that should also be 90. Okay, so and also the angle at D, this should also be 90 degrees because by Thales theorem again, this is a right triangle and because this is a triangle which is inside a semicircle. Okay, so next thing is we observe that this line DC is actually we can say that we have here another right angle at point F because it's a straight line and the other side has a right angle and same with point E, the angle inside the smaller semicircle is a right angle, then this should be also a right angle. And same with the angle at D, this should be also a right angle because also of Thales theorem since it is a triangle inside a semicircle. Okay, so and with that, we actually have three right angles and we observe that we form a quadrilateral EBFD and we saw that these three angles are 270 in total because we have three 90-degree angles and in any quadrilateral, the sum of the interior angle should always be 360. And since we knew that these three angles are already 3 times 90, which is 270, then 360 minus 270, which this will give us 90 degrees for this angle at B. Okay, so next thing that we have to do is we need to notice that the line EF, if we draw a line from E to F, this is also a diagonal of the same distance as DB because DB and EF are the diagonals of this rectangle. And in a rectangle, the diagonals are always equal. Okay, so if we find the distance DB, then we can say because of what we said earlier, it is equal to EF. So EF can be found if we find the distance dB. So, okay, so next thing that we have to do is we need to find the distance dB. But by using the altitude to hypotenuse theorem, we have dB square is equal to the segment AB times BC. Okay. So dB square is equal to AB is given as 6 and BC is 12. So dB equal to the square root of 72. And dB is can be written as equal to 36 times 2. And 36 is equal to 6 square times 2. And dB is equal to 6 square root of 2. And since EF is equal to dB, then EF is equal to 6 square root of 2 units. And that is our answer. So thank you for watching until the end of the video. Please like the video if you like our solution, and don't forget to subscribe to the channel and hit the bell icon so you will be updated for more math videos like this. Thank you. Bye.